Today we are going to see about the topic biomedical waste management. So let us start with the introduction. Actually, biomedical waste is nothing. It is any waste generated during the diagnosis, treatment or immunization of human beings or animals, or during related research and laboratory activities. Biomedical waste management involves the collection, segregation, storage, transportation, treatment and safe disposal of biomedical waste to prevent infection, injury and environmental pollution. So next we can see about the types of biomedical waste. Biomedical waste can be broadly divided into following types: infectious waste, anatomical waste, sharps waste, pharmaceutical waste, chemical waste, radioactive waste, cytotoxic waste and general or non-hazardous waste. These infectious waste, anatomical, sharps, pharmaceutical, chemical, radioactive and cytotoxic waste are considered as hazardous waste. The remaining are the non-hazardous waste. Next one is we can see about the infectious waste. Infectious waste, it is nothing, it is the waste contaminated with blood, body fluids or disease causing microorganisms. Examples: blood soaked cotton and dressings, swabs and bandages, laboratory cultures or contaminated gloves. And anatomical waste. Anatomical waste is nothing, it is a pathological waste. In hospitals, mostly the pathological waste we can see the human or animal tissues and body parts. Example, the human tissues, organ and placenta and body parts we can see in the autopsy. In autopsy we can see this anatomical waste. And next one is sharps waste. Sharps waste, the objects capable of causing cuts or puncture or injuries. And examples: needles, syringes with needles, scalpels, blades and broken glass. And next one is pharmaceutical waste. Pharmaceutical, already we know about the pharmaceutical waste. In pharmacies, mostly the tablets and medicines, we are working with medicines now. So these waste, expired, unused or contaminated medicines and pharmaceutical products, these are considered as pharmaceutical waste. Examples: expired tablets, vaccines, antibiotics and medicinal bottles. And next one is chemical waste. Chemical waste, it is the waste containing chemicals used in healthcare and laboratories. In laboratories we are using chemicals now. Many types of chemicals we are using, such as disinfectants, laboratory reagents, solvents and formaldehyde. And another one waste, the type of waste is radioactive waste. It is a waste contaminated with radioactive materials from diagnosis or treatment. Some of the examples, the radioactive materials from nuclear medicine or contaminated laboratory materials. And cytotoxic waste, this is the waste containing substances that can damage or kill cells, particularly substances used in cancer treatment. Some of the substances we are using for treat the cancer, that waste are considered as cytotoxic waste. For example, chemotherapy drug residues, contaminated chemotherapy equipment. These wastes are totally called as hazardous waste. Next type of waste is general or non-hazardous waste. General or non-hazardous waste that does not pose a significant biological, chemical or radioactive hazard. For example, paper, food waste, packaging materials and garden waste. And next type is the major it is a classification between the major and minor source. Major source of biomedical waste will be from the healthcare facilities that generate large quantities of biomedical waste. From hospitals, that is operation theatres, wards, all types of wards, intensive care units, emergency departments and laboratories. And medical colleges and teaching hospitals, this waste also considered as major source of waste. The waste generated from patient care, teaching and research laboratories. And diagnostic laboratories, the waste generated from the diagnostic laboratories are blood contaminated materials, specimen containers, cultures, chemicals and sharps. And from research laboratories, the waste generate that is biological waste, cultures and chemicals and laboratory disposals. From blood banks, blood bags, blood samples, contaminated tubes, needles and syringes. And from veterinary hospitals, animal tissues, blood, sharps, medicines and infectious materials. So these are the wastes are considered as the major source of biomedical waste. Next we can see about the minor sources of biomedical waste. These waste examples these wastes are collected from the dental clinics, small private clinics, nursing homes, health centers, dispensaries, veterinary clinics. and also home healthcare and first aid centers, tattoo piercing centers and medical camps, immunization and vaccination centers, mortuaries and autopsy centers, blood collection centers. From these the waste are collected. They are called as minor sources of biomedical waste. Although these sources generate smaller quantities, proper segregation and disposal are still essential. Next one is the categories and classification of biomedical waste. In general, how they are classified and their description and examples. Infectious waste, anatomical shafts, pharmaceutical, chemicals, cytotoxic waste, radioactive waste, and their already we have seen the nature of the based on the nature of the waste. We are classifying this waste into 7 or 8 categories now. So this is the categories of classification of biomedical waste. And biomedical waste classification under India's biomedical waste management rules 2016, it is segregated into 4 color coded categories: yellow color, red color, white color and blue color. 4 color categories. We are categorizing the classification of biomedical waste, and we are have to discard the waste into based on the categories. In yellow category, what are the waste can have to be discarded means human anatomical waste, animal anatomical waste, soil waste, expired or discarded medicines, chemical waste, microbiology and biotechnology waste, certain contaminated linen and materials. And how we have to treat the typical waste means we have to treat the waste, yellow category waste, into incineration, deep burial are permitted or other prescribed treatment methods. Incineration is nothing, it is we are applying the high temperature to burn the waste. Burning, the incineration is nothing, it is burning. And next one is red category waste. Red category, if you want to discard the waste, means you have to put in red dustbin. The red that is dustbin having the pasted with red color, coated with red color. That dustbin only you have to put the biomedical waste. So what are the waste can be put in the red container? So it includes contaminated recyclable plastic waste. For example, IV tubes, IV sets, catheters, urine bags, syringes with your needles, gloves. How to treat the red category waste means autoclaving by microwaving and hydroclaving and followed by shredding and recycling through authorized facilities. Autoclaving in the sense it is a steam sterilizer, microwaving and hydroclaving by using water we can sterilize this, treat the waste. And next one is white category waste, that is translucent or white category waste. We have to categorize the waste and put in the white dustbin. That waste are mostly from the shops including metals. Shops in the sense needles, syringes with fixed needles, scalpels, blades or contaminated sharp objects. And we have to treat by using sterilization followed by shredding or encapsulation and safe disposal as prescribed. Based on the needles or syringes or scalpels, based on the types of the shops, we have to treat the waste based on the types of the shops. And next one is blue category waste, and this includes contaminated glassware, broken or discarded glass, metallic implants, medicine vials and ampoules as applicable. And typical treatment method is disinfection, autoclaving, recycling through authorized channels. And that next one is importance of the proper biomedical waste management. The proper management helps to prevent the spread of infections, protect healthcare workers from injuries, prevent needle-stick injuries, protect patients and visitors, prevent soil and water pollution, and reduce air pollution from improper burning, prevent exposure to toxic chemicals and medicines, promote safe recycling of suitable materials, maintain a clean healthcare environment, ensure compliance with biomedical waste regulations. So these are the importance of the proper biomedical waste management. And these are the basic steps in the biomedical waste management. It is the waste generation. The generated waste is segregated and it is collected, then storage and transported through vehicles, and treatment and disposal. The main principle of the biomedical waste should be segregated at the point of generation and placed in the correct color coded container. We already have seen 4 color categories in India, that yellow, red, white and blue. Yellow for anatomical, soil, pharmaceutical, chemical and certain microbiology waste, red for contaminated recyclable plastics, white for shop, blue for glassware and metallic implants. Major sources already we discussed: hospitals, medical college, laboratories, blood banks and veterinary hospital waste. And minor sources included clinicals, dental clinics, nursing homes, health centers, vaccination centers, medical camps and home health care. So this is about the sum up of the sum up of the basic steps in the biomedical waste management. Next we can see about the hazards of biomedical waste. What are the hazards we are facing? The biomedical hazards waste can cause health and occupational and environmental hazards. If it is not properly managed, then only it will create health hazards. What are the biological hazards? Biomedical waste may contain disease causing organisms, that is pathogens. For example, bacteria, viruses, fungi, parasites. The possible effects of these pathogens may be by the hepatitis B and C, HIV infection, tuberculosis, other healthcare associated infections. So they may create diseases because they are disease causing organisms. So the pathogens may cause diseases. And next is shocks hazards. By means of these needles, blades and broken glass, these types of shocks can cause cuts and puncture wounds and needle stick injuries. They may cause transmission of bloodborne infection. How means, if you work in the healthcare facilities, for example, if in the hospital, if maybe accidentally we can cut or puncture and wounds may create by use of the blades or broken glass or needles. So needle stick injuries also may happen, and transmission of this bloodborne pathogen infections may happen because of the shock hazards. And next one is chemical hazards. Chemicals such as disinfectants, solvents and laboratory reagents may cause burns, skin and eye irritation, poisoning and respiratory problems. Mostly disinfectants mostly we can apply on the surface or surface of the that is non-living matter we are applying. For example, 70% alcohol is the example of disinfectant we can use to swipe the surface of the laboratories. And for example, in doctors we are doctors using in cotton they are dipping the alcohol and swipe and rubbing on the skin before put injection. No, that is one type of disinfectant. That is 70% alcohol is the best disinfectant we are using in the laboratories. That may if it is the concentration are high, or it may sometimes it may cause hazard in high concentration. That time it will make burns and skin and eye irritation, and may poison. Not only the 70% alcohol, but also we are using some of the solvents and laboratory reagents we are using, that may create respiratory problems also. And pharmaceutical hazards. Pharmaceutical hazard means expired or discarded medicines can cause toxic effects, allergic reactions, environmental contamination, development of antimicrobial resistance when improperly released. Environmental hazards. Improper disposal may cause air pollution, soil contamination, water pollution, bad odor and harm to animals and plants. So these are the hazards. And next one is radiation hazards. The radioactive waste can cause tissue damage, radiation sickness at high exposure, long-term health effects. Radioactive elements, they may cause hazards. And why we need for the disposal of biomedical waste, why it is need for disposal of biomedical waste means, if it is proper disposal is necessary, because biomedical waste can pose risk to patients, healthcare workers, waste handlers, the public and the environment. So main reason is to prevent the infection. Main reason is that is the significant reason is prevent the infection. How to prevent infection means to reduce transmission of the infectious diseases. Prevent means you have to reduce only, so reduce transmission of infectious diseases. Protection of healthcare workers. By protection of healthcare workers by reduces exposure to contaminated materials. And prevention of needle stick injuries is nothing, it is a safe disposal of shops, protects workers. Environmental protection means we can prevent contamination of air, some water and soil. And protection of the public, because it is a very important thing, no? So it prevents unauthorized access to hazardous waste. The hazardous waste only should be handled by the healthcare workers only, that is authorized persons only have to, the healthcare organizations will have to allow these workers only. If an unauthorized access or unauthorized persons, the organizations won't allow. That is the thing, that is the protection of the public. Safe handling of medicines and chemicals, it prevents poisoning and chemical exposures. Prevention of reuse, it prevents contaminated syringes and medical materials from being reused. And legal compliance, it ensures compliance with applicable biomedical waste regulations. That is, some regulatory methods are there in their own healthcare organizations. Each organization, they have their own policies and regulatory rules. So based on this, we have to apply this waste management based on the regulations. And improved hospital hygiene, it keeps healthcare facilities clean and safe, because if it is waste means it is not unsafe, no. So we have to keep the healthcare facilities, for example hospital, clean and safe. Resource recovery, it allows safe recycling of suitable materials. And next one is waste minimization. So how you should minimize the waste, because dumping the waste is not good, no. So we have to minimize the waste. How we can minimize the waste? The waste minimization means reducing the quantity and hazardous nature of waste generated by healthcare activities. In general, minimization in the sense reduce the quantity of the hazardous waste. So how what are the methods we are following for waste minimization? You have to avoid unnecessary use of disposal materials, and purchase medicines and supplies according to actual requirements. If you needed only, we have to purchase, or else we after sometimes we can purchase. Use reusable items where safe and permitted. Avoid excessive packaging. Use digital records instead of unnecessary paper. These, because paper also we are putting in waste, no. We are using paper. It is a difficult thing to that is create the paper or manufacture the paper and all. So we can use the digital records instead of the paper. We can use the digital things. And prevent wastage of medicines, and maintain medical equipment properly, and use products with less hazardous materials. Recycle suitable materials through authorized agencies. Train staff in proper waste management. Practice triple R cycle, that is reduce, reuse and recycle wherever appropriate. So this is about the waste minimization. And what are the benefits of the waste minimization? It reduces waste volume, it reduces treatment and disposal cost, it protects the environment and reduces occupational hazards and conserves resources. Next one is waste segregation and labeling. And waste segregation is nothing, segregation is separation. So we are separating biomedical waste according to its type at the point where it is generated. At the point of generation itself, we have to separate the waste. That is the thing about the segregation. This is one of the most important steps in biomedical waste management, and the basic principles are: segregate waste at the point of generation, use appropriate color coded containers, do not mix biomedical waste general waste. Because already we discussed about the waste then color coded containers. Based on the nature of waste, the hazardous waste and non-hazardous waste, that can be differentiated and we have to put separate containers. If it is mixed with the hazardous waste is mixed with general waste, that waste is also converted into hazardous waste. If it is non-hazardous waste, that is mixed with general waste, hazardous waste means the general waste is converted into hazardous waste. So do not mix biomedical waste with general waste. This is the important thing. Next one is, do not mix different categories unnecessarily. Use suitable bags and containers. What to say? The dustbins are there now in different colors. In that we have to use suitable bags. So 3/4 of the bags, if it is filled, means it is ready to take or transport the waste to the other side. Okay, and next one is shops must be placed immediately in puncture resistant containers, because shops it will create puncture no. So it you have to put the shops into puncture resistant containers. Then containers should not be overfilled. 3/4, if it is 3/4 means we have to remove. And healthcare workers should be trained in segregation procedures. And so these are the color coding in India. Already discussed yellow, red, white and blue. And next one is labeling of waste. The labeling in the sense, if it is in India, okay, in general, if in foreign countries are there, no, in that from one place to another place they are transporting the waste. In India also they are doing, but in foreign countries they are use the transportation vehicles, and some of the steps they follow for the labeling. That also we are international level, we are following this labeling method. That is, labeling is nothing. Biomedical waste containers or bags should have the appropriate identification and labeling as required by applicable regulation. If it is India, there it has its own regulation. Some of the waste having fully this global level, these regulations are same. The labels help to identify the types of waste. What is the type of waste? It is a hazardous waste or non-hazardous waste or cytotoxic waste. We have to that is paste the types of the waste on the container. Next one is warn the workers about hazards. Next, ensure correct handling, prevent accidental mixing and support safe transportation and treatment. So labeling is very much important. And handling, how to handle the waste. And waste handling refers to the safe practices used when collecting, moving and managing biomedical waste. That is, safe handling practices: wear appropriate PPE, that is personal protective equipment. For example, use gloves while handling waste, use mask, protective clothing and eye protection when required. Eye protection, thus eye goggles and gloves and masks and aprons. These are the personal protective equipment. Never handle waste with bare hands. Never manually compress waste bags. And do not reach into waste containers. Handle shops carefully. Never bend, break or recap used needles unless a specific procedure requires it. Use puncture resistant shops container. Wash hands after handling waste. Clean spills immediately using appropriate procedures. Report injuries and exposures immediately. So these are the waste handling procedures. Next one is collection of the biomedical waste. The collection is nothing, it is a systemic removal of segregated waste from the point of generation. At the point of generation itself we have to segregate. And the collection procedure, the waste is placed in the correct container at the point of generation. The containers are checked for proper segregation. Bags or containers are securely closed. And the collection of biomedical waste is collected during designated equipment. Collection staff use appropriate PPE, that is personal protective equipment. Waste is moved through designated routes, that is transportation. The short route will be preferred for the transportation of waste from the segregation point to the disposal site. Waste is taken to the designated storage area or treatment facility. The collection records are maintained where required. And what are the important points in the collection points? That is, collection should be performed regularly. Avoid unnecessary accumulation. Waste bags should not be overfilled. Already I told, no, 3/4 of the waste is filled means we have to remove the bags and to the disposal site. Shops containers should be replaced before they become excessively full. That is, if it is overfill means we have to replace. Damaged or leaking bags should be safely contained. And next thing is storage. How you have to, if it is tons of waste means you have to store in particular place. No, so storage means keeping biomedical waste temporarily in a designated area before treatment or disposal. Before the waste have to before the treatment we have to keep the waste in the particular area. That is the storage. What are the requirements of the storage area? And it should be secure and access controlled. It should be clearly identified. It should be protected from animals and unauthorized persons. It should have an easy to clean floor. It should have adequate ventilation. It should be protected from rain, sunlight where necessary. It should be regularly cleaned and disinfected. Waste should not be stored longer than permitted by applicable regulations. That is, the area is not near the kitchen and all. It should be a separate area, and it has the water facilities and ventilation facilities, and it is protected from rain and sunlight. So these are the things we have to keep it in mind in the storage of biomedical waste. And it is a important principle of the storage of biomedical waste, that is, it should not be stored unnecessarily for long periods. 48 hours is minimum 48 hours. Within 48 hours you have to transfer the waste into the treatment or disposal site. So unnecessarily you should not store the waste for longer periods. And next one is transportation of biomedical waste. Transportation means moving biomedical waste safely from the generation point to the storage, treatment or disposal facility. Transportation by means of vehicle. We are safely transfer the waste from the generation site to the storage or treatment or disposal point. What are the types of the transportation? Internal transportation and external transportation. Internal transportation in the sense movement within the healthcare facility. For example, if it is in a hospital. External transportation means movement from the healthcare facility to an authorized treatment or disposal plant or disposal facility. So what are the safety measures for the transportation of biomedical waste? Use designated trolleys or containers and keep waste bags properly closed. Use leak-proof and puncture-resistant containers where required. Do not transport waste together with patients, food or cleaning materials, and follow designated routes. It should be the smallest, that is fastly we have to reach, that route will be followed for the transportation of waste. That is, within the minimum time we have to reach the that area, disposal area. That route will be followed. Clean and disinfect reusable transport equipment. Transport equipment will be very clean with the disinfectant, and we have to reuse the equipment. And external transportation should obey with applicable regulatory requirements. So these are the safety measures. And treatment. Next one is treatment of the waste. The treatment is the process used to make biomedical waste safer before final disposal. So major treatments methods are there. One of the method is autoclaving. It uses steam under pressure to destroy microorganisms commonly used for contaminated plastics, microbiology waste, certain reusable or recyclable materials. And microwaving, it uses microwave energy to disinfect suitable biomedical waste. Hydroclaving, it uses steam and pressure to treat suitable waste. Incineration, it uses high temperature combustion to destroy suitable biomedical waste. It may be used for certain anatomical waste, soil waste, pharmaceutical or cytotoxic waste as permitted. And next one of the treatment of biomedical waste is chemical disinfection. It uses appropriate chemicals to destroy microorganisms used for selected liquid waste, laboratory waste, surfaces and equipment. Already I told no, in chemical, that is alcohol is a disinfectant and all. And shredding is mechanical size reduction of appropriately treated recyclable waste. For example, shredding, it is important in shredding. It should be carried out only after the waste has been appropriately disinfected and treated. After the disinfection and treating the waste, we have to shred the waste by means of some mechanical cutter. Needles are mechanical cut, that is shredded by mechanical cutter and all. And next one is disposal of this biomedical waste. Final stage is the disposal. The disposal means the final safe management of treated biomedical waste. Common disposal methods, that is authorized recycling, incineration, secured landfill for appropriate treated waste, deep burial where specifically permitted, encapsulation for certain waste streams, disposal through authorized common biomedical waste treatment facilities. The selected method depends on the type of waste, treatment requirements and applicable regulations. And so this is about the flow chart in the biomedical waste management. First, the waste is generated, and generated waste, how much we can minimize that, we can minimize the waste by using waste minimization method, and segregation or separation of the waste at the source itself. Next one is labeling and color coding the waste based on the types of the waste. We have to label and we have to put in the separate container, that is yellow, red, white and blue, and collect the waste. Collection of the waste. Next one is temporarily you have to store the waste and transport the waste by means of vehicles in the short routes, and treatment the waste by means of many methods, and finally disposing or recycling the waste. This is about the biomedical waste management flow chart from the waste generation up to the final disposal or recycling the waste. Next we can see about we can conclude the topic, the biomedical waste management. The biomedical waste management is an essential part of safe healthcare practice, and proper waste minimization, segregation, labeling, collection, handling, storage, transportation and treatment, disposal help prevent infections, injuries and environmental pollution. Healthcare workers must follow proper color coding, use appropriate PPE, that is personal protective equipment, and comply with biomedical waste regulations. It is effective biomedical waste management protects patients, healthcare workers, the public and the environment while promoting a clean, safe and sustainable healthcare system. So this session will be useful for you. I feel like that. Also, with this I am concluding this. So thank you.